All right, we're working with trig form or polar form of complex numbers today. And so I've written out here to the side, we've got this complex number, -3 minus root 3i. Remember, there's our a, there's our b. We're really familiar with complex numbers. Well, here's just another way to represent that in polar form or trig form. So r times cosine theta plus I sine theta. R is basically the absolute value of this number. I like to relate this to vectors, to things that we've already done before. So let's maybe just plot this. And I put this here just to guide me. It's not a big deal. Just draw a rough triangle. So if we start from our origin and we go over 3, right? And then we go down root 3. That's about 1.7. Again, don't stress it about the scale. So here is our triangle that we can generate. That'd be nice. Pretend it's there in the origin. Okay. So this side is -3 and this side is -root 3. And we basically want to figure out, well, what's our r? Hey, it's just the hypotenuse of a triangle, right? That's not hard to figure out. And then theta, we're going to figure out basically what this whole angle is. There's a couple different ways we can do that. So let's get r first of all. So if I come over here, if I do the square root, or I'm sorry, not the square root, but if I do, okay, just forget that. If I do 3 squared plus root 3 squared, I'm doing Pythagorean theorem, right? Well, 3 squared is 9, root 3 squared is 3, so 9 plus 3, so that equals 12. And if I do the square root of 12, that's what I was doing there, sorry, then I would get 2 root 3. So r equals 2 root 3. That's the magnitude or the absolute value. Magnitude, if we were doing vectors, I guess is the word we'd use. So we know what r is. Hey, now we just need to figure out direction. There's a couple different ways we could do that, okay? So let me just identify this as like, I'll do theta prime, like a little reference angle going way back in the class. So tangent of that angle would be -root 3 over -3. Negative divided by negative is 1. And so I could do the arctangent of root 3 over 3. Now if you go plug that in your calculator, you're going to get 30 degrees. You could do rads, but I do degrees whenever I can if they don't specify. Hey, so this angle is 30 degrees. Of course, here to here is 180. That makes the whole thing 210 degrees. Not too bad, all right? So now if we put this thing together, z equals 2 root 3 times cosine of 210 degrees plus I sine 210 degrees. And there is our answer, our complex number in trig form or polar form. I hope you can see how that relates to things we've been doing. Really, it's not new at all. Okay?